Hello, another A-level multi-choice question. If you want to choose a different question from the same topic, click on the information card over here. If you want to answer the question yourself, pause the video now. Got the answer D. Well done. Keep listening if you want to hear my explanation. In the circuit below, the voltmeter reading is 0. When the temperature of the thermistor increases, the voltmeter reading changes. Which change to the circuit will restore the voltmeter to 0? Well, the reason the voltmeter reads 0 is because the PD across P must be the same as the PD across R. We can also say that the PD dropped across each resistor in each branch is equal to the proportion of the resistance of each of those resistors. So I can make the following statement. I can say that the potential difference across P over the potential difference across Q is equal to the resistance of P and the resistance of Q. Now, given that that's a true statement, I could also say that the potential difference across R and the potential difference across T is equal to the resistance of R over the resistance of T. Given the fact that these potential differences across P and R are the same and across Q and T are the same, I can now write the following. I can say that the ratio of resistance of P over the resistance of Q is going to be equal to the ratio of resistance R over resistance T. Now, when the temperature is increased, the resistance of the thermistor will decrease. So that ratio is going to change, and what I need to do is find out what I can change with resistance R, resistance P or resistance Q to restore or to make these ratios the same again. So one thing I could do is I could reduce the resistance of R. That would restore the ratio. I could reduce the resistance of Q, or I could increase the resistance of P. Pause the video now if you're not 100% happy where I got these ideas from, but you'll find that they're all true statements. So let's have a look which of these statements agrees with one of these possible answers. A reduction in the EMF of the cell? No, that wouldn't work. That wouldn't restore these ratios at all. A reduction in the resistance of P? No, we said we needed an increase in the resistance of P. An increase in the resistance of Q? No, we said we needed a reduction in the resistance of Q. A reduction in the resistance of R? Yes, a reduction in the increase of R will restore the ratios. So, I hope you found this useful. If you did, click on that subscribe button. Please watch more of these in the video. Please share with people who are also studying physics, and thank you for watching.